welcome to today's webinar, Efficient Drainage Modeling for Housing Developments, Best Practice Case Study, which is part of the Autodesk Water Webinar series. I'm Olivia Tempest, Editor-in-Chief of Smart Water Magazine. Thank you so much for joining us. In this session, we'll explore the growing challenges of drainage modeling for housing developments. With tighter sites, limited green space, and increasing planning pressures, traditional methods, especially spreadsheets, are no longer up to the task. These outdated tools are prone to errors, lack scalability, and can't optimize designs effectively. With the UK's new national SuDS standards, designers must integrate sustainable drainage systems on all developments. This makes adopting smarter digital tools essential. By switching to scalable software like InfoDrainage, engineers can avoid common pitfalls like underestimating flows, overestimating storage, and wasting design time. These tools integrate with CAD platforms, enabling real-time visualization and optimization of drainage models. We're excited to have today Simon Renfrey, Business Development Manager at Symmetry, and Brian Jones, Associate Engineering Director at Newland Homes, to share insights on these next-generation tools and techniques. But before we dive into the webinar, a few practical details. By attending today, you are eligible for a CPD credit. Please scan the QR code displayed on your screen to receive your certificate of attendance. If you prefer to follow in a language other than English, you can select your preferred subtitles at the bottom of your Zoom window. And we also invite you to submit your questions at any time during the session. Our speakers will address them during the Q&A at the end of the webinar. Please, to do so, use the Q&A panel at the bottom of your Zoom window and remember to include your name and organization. Now it's time to meet our speakers. Our first speaker is Simon Renfrey, Business Development Manager at Symmetry, a leading Autodesk Platinum partner. With over 30 years of experience, Simon specializes in Autodesk water solutions and works with authorities and consultancies to improve drainage workflows. Today, he'll discuss how modern tools like InfoDrainage help overcome common challenges in drainage design, replacing outdated spreadsheet methods. Next, we have Brian Jones, Associate Engineering Director in Newland Homes. With 23 years in the industry, Brian will walk us through a real-world case study from a greenfield site in Pittville, Cheltenham. He'll demonstrate how he efficiently integrated SuD features and optimized drainage design to balance cost and storage requirements using InfoDrainage. And lastly, we will welcome Idris Nuju, Technical Solutions Engineer at Autodesk Water, to moderate our Q&A session. With this, I'm delighted to hand the floor over to our first speaker, Simon Renfrey.
Thank you, Olivia, and great to meet you all. I think I'm sharing my screen now. Yes, brilliant. So yeah, thank you for the introduction. This is a subject that I'm very passionate about, so I'm excited for the opportunity to speak with you all today. And also pleased to be joined by Brian, who's someone that I've known for a very long time, since the microdrainage days. Before we move into the case study with Brian, I just want to give you a quick overview of Symmetry, where we can support you, and also provide an overview to the Autodesk Water Solutions. So as Olivia mentioned, I'm Simon, a Business Development Manager at Symmetry, and I specialise in the Autodesk Water Solutions across the UK and Europe. My role focuses on working strategically with water utilities, local authorities and consultancies in the water space to help them strengthen how they adopt and apply solutions such as InfoDrainage and InfoWorks ICM. I work closely with leadership and technical teams to ensure that these platforms are not just implemented, but embedded effectively into their work processes, supporting governance, improving review robustness, and building long-term capability within organisations. Across the UK and Europe, we're seeing increasing pressure on authorities to review drainage and flood risk submissions with greater scrutiny and efficiency. And a key part of my role is helping organisations respond to that challenge with the right combination of skills, processes, and technology. Symmetry is a trusted digital transformation partner to the built environment. And as Olivia mentioned, we're a leading Autodesk Platinum partner operating across the UK and Europe. We've been supporting architecture, engineering and construction organisations for over 30 years. And a big part of our focus is water, drainage and infrastructure workflows. That means that we understand not just the software itself, but how it's actually used in practice, particularly within planning, flood risk and drainage review environments. And our support goes beyond just supplying licenses. We provide consultancy, implementation and structured training, helping organisations embed solutions properly rather than just adopting them at surface level. We work closely with house builders and drainage design consultancies to help strengthen the quality, consistency and defensibility of drainage submissions, making the review and approval process smoother and more efficient for all parties involved. Ultimately, our focus is about empowering teams, improving compliance, strengthening collaboration, and increasing confidence in the data being submitted and reviewed. When we talk about how we support house builders and their drainage partners, it really comes down to reducing risk and increasing confidence, both at the planning stage and through delivery. Starting with infra drainage, we provide structured training from foundation through to advanced levels, tailored to design consultants and in-house technical teams producing sustainable drainage design strategies and detailed drainage submissions through including integration with Civil 3D. Our focus is on helping teams to produce clear, compliant, review-ready submissions first time, aligning local authority expectations to minimise back and forth, redesign and project delays. We also help you to establish templates, standards and repeatable workflows across multiple developments, and that consistency is key for regional and national house builders who want predictable approval outcomes across different authorities. As well as supporting infra drainage for detailed drainage design, we also deliver certified training for InfraWorks ICM, Autodesk's platform for flood modelling and impact assessments. Our InfraWorks ICM training course is designed for drainage engineers who want to confidently build, run and review hydraulic models. We cover everything from setting up 1D and 2D models, importing GIS and rainfall data, and validating networks through to analysing results, reviewing long section, and producing clear outputs for reporting. As an outcome, your team will be able to design and assess storm and foul networks, model flood risk scenarios, and produce robust defensible results to support planning applications and impact assessments. So as your projects scale from site-level drainage design to catchment-wide flood modelling, we can support you with both the software and the skills. So the Autodesk Water solutions capture the entire value chain, covering the full water life cycle. They support digital transformation to manage every drop of water across the asset life cycle, covering from planning through to digital operations. When we look at the Autodesk Water solutions through a house builder lens, it's really about reducing risk, improving approval certainty, and delivering sustainable drainage schemes that stand up to scrutiny. Infra drainage supports the design phase, allowing teams to size, test, and present sustainable drainage solutions clearly and in line with local authority expectations. And it provides visual, transparent outputs that make submissions easier to review and justify. InfraWorks ICM then takes that design further, validating how the site performs hydraulically under a range of storm events, including climate change and exceedance. This is particularly valuable on larger or phased developments where wider catchment interaction needs to be understood. Once those assets are constructed, InfoAsset supports the operational side, creating structured asset registers, inspection plans and maintenance schedules. This is especially useful when preparing for adoption or long-term management arrangements. And then alongside this, InfoWorks WS Pro can support with potable water modelling where required, ensuring infrastructure planning is aligned across networks. When combined with Autodesk's core solutions like Revit, Civil 3D and Autodesk Construction Cloud, Autodesk delivers a comprehensive set of solutions for end-to-end water lifecycle management. What's powerful is how these solutions can work together as part of a connected workflow. You might begin in infra drainage, developing your attenuation strategy, infiltration features and flow controls, producing compliant outputs for planning. As schemes become more complex, that design can feed into InfoWorks ICM, where you assess wider flood risk, run 1D and 2D simulations, and understand downstream impact across the catchment. At the same time, your levels, corridors, and surfaces are being developed in Civil 3D with the Civil 3D infradrainage integration, ensuring drainage design and site geometry stay aligned. Then, through Autodesk Construction Cloud, all models, drawings, and documents are shared in a controlled environment, giving planners and consultants and contractors access to the right information at the right time. The result is a connected workflow from concept drainage design through to drainage modelling to detailed design and construction, reducing rework, improving collaboration, giving you greater confidence in your submissions. So I'm now about to hand over to Brian, who's going to run through the case study, talk about how he handles challenges around having incomplete or poor quality site information, facing increasing planning and regulatory pressures, ensuring drainage designs are not overcomplicated, leading to inefficient modelling and wasted drainage design, reducing the reliance on spreadsheets with evidence-led and optimised drainage systems, ensuring accurate designs to reduce the likelihood of costly, oversized storage structures or unreliable and risk-heavy designs leading to increased flood risk, and finally, workflow and scalability challenges. Thank you. I shall now pass over to Brian.
So we've done that. Yeah, so when I started my career, screens were that big. AutoCAD was fairly basic, and we saved all our work on floppy disks. So I've been in the industry a while. Newland Homes is proud to be the first house builder in the UK to sign up to the United Nations Climate Change Neutral Now pledge. We are building zero carbon homes and have been since 2022. And over those few years, we've built over 510 zero carbon homes. So we're quite proud of being into our SuDS and that sort of thing. So we try and do the right thing, if you like, in terms of development. As one of our sites in Tickenham. Efficiency drainage modelling for housing developments, best practice. If you're still using spreadsheets or struggling with overcomplicated drainage models on housing sites, with tighter sites and increasing planning pressures, inefficiency, drainage modelling can lead to unreliable results, inflated storage requirements, and wasted design time. So I'm going to be covering in this seminar how we build efficient drainage models without unnecessary complexity, move beyond spreadsheets, which is where I started doing my drainage design many years ago, and how we integrate SuDS onto tight sites and avoid the pitfalls of increasing storage volumes and risk. So the design process that I'll be going through, reviewing available information on any site, determining what's missing and obtain that information. Visiting site is an important part of the process. Identifying the constraints on the site is key. So where's the access going to come from? Where's the points of discharge? What services are crossing the site that will affect our design? And then developing an outline drainage solution, calculating the greenfield runoff rate, identifying the main attenuation features and where they're going to be on the site, identifying the main sewer routes, and then adding any secondary SuDS features. And finally, designing a detailed scheme that we can submit for approval. So the site I'm looking at is in Pitfall, as was mentioned earlier. It's on the north side of Cheltenham. It was part of the Pitfall School. It was an old playing field that was no longer needed. In fact, the development of the site is funding a new sports centre to help redevelop the school. You probably see that Cheltenham Racecourse just off in the north of the picture. So it's in a highly desirable part of Cheltenham. It's got an previous development on the east side that was built a little while ago, and that's where the access will be coming from. There's Gloucester College School next to us. And then to the south, there's an old development, probably 1920s, 1930s, with some quite old drainage systems in it. So gathering the background information, part of that is getting the service record plans. So you can see from this, you've got existing sewers down off the south in what's called Cakebridge Road. There's also sewers off to the west beyond Gloucester College in Albert Road. And then the recently built development off to the east has got the green sewers in there, which haven't been adopted yet. So part of the information we gather is the topographic survey. So that's useful in identifying utilities and existing services in detail, and the ground information. So we did percolation tests on the site, identified where the permeable soils might be, and tested at appropriate depths. Unfortunately, on this site, despite the fact there are some sands and gravels on the site, they were too dense to get a sufficient percolation rate for any permeability. So looking at the site survey in detail, we could identify the points of discharge. So looking down Cakebridge Road, there's a surface water sewer there at that point. And then a bit more detail on the left, you can see closely, there's a manhole there we can connect to. The foul drainage is slightly too shallow at the top end of the road, so we thought we'd need to take the sewer further down, so we can design both of those. And we can check that there aren't any services clashing because we've done a utility survey. So the first part is to look at the site and establish a discharge rate into those existing sewers, assuming there aren't any capacity issues. So the first thing is to calculate the greenfield runoff rate. Now, the site was designed in April. At the time, it's not that far long ago, but at the time, there were some inconsistencies between the LFA's approach on calculation of greenfield runoff rates. To use the site area or the impermeable area only. Some LLFAs insist on just using the impermeable area, while others will let you use the total site, but insist on increasing the CV value for your calculations from 0.84 to 1. Or including the greenfield the green areas, the permeable areas, if you like, into an allowance for those in your runoff calculations. Since then, the national SuDS standards have been issued and clarified the process, if you like, reusing the total site area and not increasing the CV value. So the greenfield runoff rate in infradrainage, there's a bar running along the top of the screen, which I'm sure you've all seen if you've used the software. So if you click on the preliminary sizing area, you can click on the tab to calculate the in the UK and Ireland the rural runoff area. Now that takes you to the screen below, which shows the calculator. And if you click on the map, you can pick up and identify your exact coordinates on the map of the UK. And there's one for Ireland as well, obviously, on the other tab. It would be nice if it automatically remembered those coordinates, but it usually resets itself to a point off to the north west of the UK. But it's easy enough to find where you need to go, and that will then give you your FSR values for the SAAR and the soil for your catchment. You need to select the region, so make sure that the region's in the right area. But from that, you can easily calculate your rural runoff and your Q-bar value to estimate your storage. So the site area for this site was 0.942 hectares. So from there, you can do a quick storage estimate using the tab to the left. Pop in your site area and again your discharge rate and do a quick calc, and it comes up with a range of volumes for your storage. So taking somewhere in the middle of that volume, because we know we're adding some SuDS, so this is probably going to be an overestimate of what we need. We can plot a pond or a attenuation feature that is an appropriate depth and area to give you that volume. So then passing that back to our architects, they came up with a layout for the site and how we were going to develop the site. As you can see, it's reasonably dense. Being in the middle of Cheltenham, there's very little open space. So the pond has been squeezed in to the bottom. Lots of houses running around a road system. There leaves very little options for SuDS. So the design team prepare the sketch. Our sales team will then put house values to that sketch, and I'll add on a preliminary design for the drainage. Our commercial team will estimate, will prepare a feasibility estimate for the development based on construction costs from previous developments, and then the land team will do a deal with the landowner to buy the land at an appropriate value, and the land is secured. So after we do that process, then we move on to the detailed design. So we'll CAD up the layout, detail the drainage in a lot more detail to make sure it all works. Draw it all out on AutoCAD and then pass it over onto InfoDrainage. So in InfoDrainage, once you've drawn it, you can import surface data from any 3D ground modeling software that you might have. Various formats for doing that. PWF or directly from a 3D CAD file, or you can load it from a surface model. So, but be careful how much data you do import into InfoDrainage. Only import what you really need, because the file sizes can increase quite rapidly if you import everything, especially on larger sites. So it's important to limit the CAD data that you import. Remember, it's a model, not you're not trying to replicate reality. So likewise you can import the drainage design. If you've done one in microdrainage, you can import that. If you've just prepared the lines on CAD, you can import those. So if you're importing the lines in CAD, you trace over it. If it's from microdrainage, it'll come with all the levels and everything brought in like this. This is an example of an imported design from CAD. You could see the surface water lines and any ponds or other features that are imported from microdrainage will appear as a square box typically. If you're tracing over and drawing your own network, there is a snap tool to allow you to snap to manholes, etc. On your imported CAD layout. So the next step is to add your pond. So again, you can import the outline for the pond from AutoCAD, or whatever other control that you want to use as your main storage. Ensure that any polylines in CAD are closed and that all arcs are removed, because InfoDrainage doesn't like importing arcs at the moment. So there are various apps that you can add into your AutoCAD to convert arcs to segments. to sort that out if you don't draw it, rather than breaking them all up yourself. So you go to import, go to stone control, and then select on your layer. So make sure each device type is on its own layer. So if I'm importing that pond, now that would import both of those lines. So if I simply wanted the top or the bottom of the pond to be imported, because if I import both, if I bring it in with them both complete and with arcs, then it'll bring me in 2 ponds. So one of those lines I should probably break so that it's not a complete polyline, and then it'll just import one of the lines. I'd usually do the bottom. So it brings in the bottom of your pond, and then you select pond when it comes in what type. So you tell it what type it is, and then you can define the parameters of that pond. So the area, so the depth and the area at the bottom, area at the top, and your levels. And then you need to go on to your advanced tab as well and give it a Manning's value so that it actually models the path of the water across the base of your pond or basin, depending on what it is. And you can define any infiltration rates if it's an infiltration basin. So when you've done that, you'll notice that those 2 pipe lengths are missing, going inlet on your outlet. So we need to connect the system back up and define those 2 pipes to be the correct diameters that you need. So that one you can specify if you've got a pond in there, previous pond, the square one, you can redefine your outline to suit something that's imported, but I tend to delete them and reset them. You can add any other significant SuDS features in the same way, but don't overcomplicate the model. Be wary that small pipes or short pipes and small manholes can introduce modeling inconsistencies. So if you try to replicate real life too much, you'll introduce spikes in your hydrographs, and it doesn't generate a decent modeling. So now we've got the pipe structure and the pond in place, we need to bring in your impermeable areas. If you've imported inflows from micro drainage, they will be square boxes at the end over each manhole or each node. As I tend to import them from AutoCAD, so I draw polylines around each of my different impermeable areas, my houses and my drives. There are other ways to do it these days, but I've not picked up on those yet. Again, make sure the polylines are closed and all the arcs are converted to segments. Alternatively, you can draw them manually, but that's quite time consuming and cumbersome. So I tend to import them where we can. I tend to do the houses and house garages, drives separately. So that because they usually have a urban creep factor of 6, whereas roads tend to, you don't apply an urban creep factor to. So I'd import the house garages and drives first, and then the roads as a subsequent import later. So once you've imported your flows, you need to make sure they're connected to the right place. They will automatically snap to the nearest manhole if it's within the curtilage of the impermeable area or within the boundary. So not all of them will connect, and they won't necessarily connect to where you want them to. So you need to go around and reconnect the inflows. So using the connect inflows button on the build. So then we need to add the control manhole. So you select the control manhole, you can double click or right click on it. and add the hydro brake. So if you go to outlets on your manual and then select hydro brake from your outlet type, there's other options available, but hydro brake is what we tend to use. And then you can define your design terms and click calculate. And then it'll contact the Hydro International website and bring up the hydro brake details. Takes a minute or so, but and then click OK, and that will fix your hydro brake. Designing the sewers, you can if you select each of the items individually, you can define what appears on the sides of your sewers. So it might just be the name of the pipe initially, but if you use the property settings, you can define what appears on there, and the display settings will allow you to change the text size and the icon size, because sometimes they can be far too large depending on the size of your site and the detail you want. Yeah, so there's the properties box that goes along with the pond, and you tick the items you want to appear on the left-hand side of that box. You can create profiles running through each of the sewers. If you go to flow on the bottom left-hand corner and click auto profile outfalls, easy for you to say, then it'll automatically create a profile for each end of of your design network, starting at each end of your design work and ending at the outfall. And then you can present the profiles like so. We can apply a renumber. We can renumber the scheme. So you can apply a numbering scheme and it'll rename the pipes and renumber the manuals for you in whichever method you want. So the build connections box allows you to bring up the network. So it shows you the connection type, pipe lengths, and defines the network, and you can change the manual and cover levels easily through doing that, and alter your levels as you need. If you click on that button at the top there on the left hand side, you can the branches will appear in hierarchical order so that you can display it in a way that's more akin to what you might be used to on micro drainage, and in order of the pipes. So naturally it appears in a fairly random order. Actually, I think it's the order in which you drew them, so it's not necessarily the order you want them. So let's go back again a minute. So if you click on the network design wizard next to that, then you can automatically design your sewers. Now, if we leave it do the design itself and just fix the outfall like that, then it'll resize all the pipes and change all the inlet levels according to our design characteristics or design criteria. So if we pick FSR and the return period, and then we want to use the flow restriction, so we click the flow restriction, and then change the default pipe sizes, so the minimum is 225. Then we'll end up with a redesign that minimizes the pipes sizes. So some of these are a lot smaller than they were shown previously on my initial quick design. So the changes are highlighted in yellow. So it's changed all the levels, changed the slopes, but notably, it doesn't change the ponds or the SuDS features. So you'll notice there on the bottom there, you end up with a negative gradient. So it's trying to make it flow uphill into the pond. which obviously is not what we want to do. And it's also dropped the hydro break, so it's not in line with the level of the pond. So you can use the connections, build connections to alter it manually and reset the levels to something that works for you. But the way I prefer to do it is when we're doing the design in the first place, the network wizard in the first place, if you do a design that is sensible initially in terms of levels, then, and you lock all the levels on all the pipes, then it doesn't change any of the levels. It just changes the pipe sizes to suit. Now, some of these pipes are a bit bigger than they were on the last one, but at least the design is sensible, and it warns you where you've got some covers that are below your minimum criteria. I mean, 732 is a bit low, but the others are, a bit of concrete protection, and that'd be fine. So then you get a network that has gradients that work for you. You need to check the velocity, minimum velocity on a surface water pipe is more than 1, which in this case, one of the pipes is too flat. So we'll need to steepen that, but we're not far off. And your design will look a bit more sensible like that. So the next step is to model that pipe network for the storms. So we can do that easily in the analysis criteria. So you've got your storm definitions in there. You can define your parameters, your return periods, and your storm durations. The default are selected there, but you can set whichever ones you want. Before we run the analysis, there's a validation that the software runs. It makes sure that everything is connected, if you like, and there's all the parameters are set. It doesn't necessarily mean they're connected in the right way. So it identifies any unconnected inlets and outlets, any unconnected inflows, unconnected controls, or missing design parameters. It doesn't validate your design. It doesn't check for poor design. It doesn't check for uphill gradients. It doesn't check that you've connected inflows to the wrong location. So you still need to be pretty careful what you're doing. And then once you've sorted out all the issues, which you can do by clicking on those individual items that are highlighted. So you can click on these individual items and it'll take you to the right place to correct them. So once it's validated, you can click go and run the analysis, and it'll tell you how much capacity you have in your pond. So if you click on critical storm, it'll bring on the worst storm, which is this 100-year 2,880 minutes, and tells you there's 20% capacity. If you click on critical return by return period, it brings up the storm that you have selected. So in this case, it's the 2 years, worst case for this 2-year storm. So we can see from this that there's no flooding in the 30-year storm. You can see it there, 30-year storm. There's no flooding in the 30-year storm, which is fine. But during the 100-year storm, we have a bit of flooding. So yeah, we've got a bit of work to do to get this system to work, or we need to ensure that the flooding is retained within the catchment. But as it's fairly a high density scheme, we probably need to make sure that that stays within the sewer network. So you can analyze the network and the results that you've got by doing an audit report. And if we select flood warnings, as well as the discharge rate and the discharge volume, and then run that, it will give you some results from the system. So we can see from here where the flooding volume is, where the flooding is, and what the volume is that we need to deal with or retain on site. And then checking the discharges rate, we can see that the actual discharge is less than all the control discharges that we had in our greenfield runoff calcs. You can check the discharge volume against the 100-year, 36-minute, 360-minute storm. See that passes. And you can check it against the no runoff, or the runoff, the 5 mil runoff rate. You can see this fails, which isn't surprising because we've got no sets in there and no percolation. So once we'd finished that design, submitted for planning, the planning process has always changed the layout that we had. So we ended up, rather than connecting down into Cambridge Road, ended up having to run a zero along through the trees into an existing ditch on the west by Albert Road. So the design changed. So it wasn't too much of an effort just to swap the pond ends round and connect everything in. So we needed to redo the model, as you can see, and we added in some SuDS features. So if we go back to that, the detailed design, you can see the green areas are small swales that we've managed to squeeze in to try and introduce some SuDS into the scheme. And there are some filter trenches in some of the driveways as well to do the same thing. So we've added the swales in. As you can see, I've not modelled every single pipe. I've just connected the end of the swale to the nearest manhole, rather than breaking the pipe up into lots of little bits where each connection is with branches. You've got to remember it's a model and it's not actual. If you put too much in there, we'll have too many short pipes and the modelling can become unstable. So if we run the new scheme again, you can see that all the swales got capacity, and the pond is as well. That scheme's a little denser, so there's a bigger impermeable area. So the capacity in the pond has gone down, despite the fact we've got all those swales. And modelling the pipes as well, we can see that there's no flooding in that system. So the amended layout, we run the wizard again as before. And you know, we reduce the pipe diameters throughout. So yeah, when we were running that model, you might notice that some of these pipe diameters are quite small, 375s. So you can reduce them too much by doing the pipe size reduction while you've got the swales in there, because when you do the when you model those storms, you'll end up with more flooding and cause yourself more problems. So we need to run through and increase some of the pipes to make it bigger. So by comparison, this is the original design without before we'd run the wizard. So you can see that the water line top water line in there is quite low, but as soon as we ran the wizard and reduced the pipe size, it's not by too much. You can see that the flooding runs through right up to the top, and you can see that it's probably these pipes down here that are too small, so that we'll release the water to escape. So to conclude, we've identified the most suitable point of discharge, calculated the greenfield runoff rate, determined the required size of the main attenuation feature, design the main sewer network, use the wizard to optimize the pipe sizes, analyze the network to ensure it complies with the design requirements, and add SuDS features that are provided at source. Thank you.
Thank you so much, Brian and Simon, for your insightful presentations. We've seen how shifting from manual spreadsheets to more scalable integrated workflows can transform drainage modeling, especially in managing planning pressures and tight site constraints. The Pittville case study has given us a clearer understanding of how to effectively balance SuDS integration with cost-efficient design to achieve practical real-world outcomes. Now it's your turn I'm talking to the audience to be part of the discussion. We have time for your questions, so please submit them through the Q&A module at the bottom of your screen. And don't forget to include your name and organization. To help guide this conversation, I'm pleased to introduce Idris Nuju, Technical Solutions Engineer at Autodesk Water, who will lead the Q&A session. All yours, Idris. Idris, we can't hear you. You're
sorry
on mute.
about that. Thanks for the introduction, Olivia, and thanks, Brian, for a very interesting presentation. So we've had a few questions come in throughout the session, and I'm going to start off with one that's slightly technical, obviously directed at Brian. So the question is, have you used or are you using variable outfall rates to match the greenfield runoff for specific storm events? For example, Q-bar for 2 to 3 year return storms, or Q100 for 1 in 100 year events.
I tend to use Q-bar, but yeah, the design check I did towards the end did compare the 2-year, 30-year, and 100-year events against the greenfield runoff rates for those figures. So you can do either.
You can do either. Okay, so the modeling approach allows for such variations when estimating the storage requirements. That's the sort of follow-up question.
Yes, it does. It uses either. Yeah.
Okay, and next I have a question from South Africa. The question is, how easy is it to create a new proposal option for this site? How easy is it to rework and update critical design elements such as the slopes, the conduit slopes?
Well, you use the build. If you use the build and connections tab, you can redefine all the invert levels, cover levels, gradients, or you can open up your flow paths and do it on your effectively your long sections, so you can change all the invert levels, cover levels. If you want to redesign the levels on it, if you want to move manholes along, you can just drag them on the plan. So it's quite easy to redefine everything.
Okay, so I've got a next question is from Italy. I think you probably covered this, but you probably go over it again. Question is, in which way is it possible to optimize the selection of pipe diameters for the entire drainage system?
I think that's using the wizard, the network wizard. It's whether it's worth doing all your levels on the wizard and gradients to meet minimum requirements. It will depend on the site. But if you're going to do that, it's probably better to do that and then add your suds later at the right appropriate level. But if you've got a small site like I had, then it's probably easier just to redesign your pipe sizes using the wizard rather than levels.
Okay, and next I have another question from the UK, I think, and it's, do you have a preference for FSR or FEH rainfall data, and why would you use either?
So FSR data is the old school data, if you like, that's been around since the 80s. It's fairly out of date. And I tend to use that on initial feasibility work, early days. When you're doing detailed design, most LLFAs are insisting on FEH data, which is more localized rainfall data for your catchment.
Okay.
So which you have to pay for, which is why I'd use the FSR for feasibilities when you don't know the design's progressing necessarily, and then switch to the FEH as the design firms up.
Okay, so another question. So what do you find causes you the most difficulties in getting local authority approval?
It's putting, so highway authorities tend not to want SuDS features, in my experience. Most highway authorities tend not to want SuDS features within the highway envelope because they don't want to have to look after them. So on tight sites like this, is fitting SuDS in and around the roads that don't want to be adopted. And water authorities, they will adopt them now, have to, but they don't necessarily want them, to be honest. They want the pipes, not the ditches, not the swales and other features. So it's fitting everything in.
Okay, and next question. Lead local flood authorities, the LLFAs, question is we tend to find that they provide inconsistent data. So do I find this? And if you do, can you elaborate a process for sort of ensuring accuracy, especially when calculating the greenfield runoff rates?
I'm not sure I follow the question, to be honest.
Okay, so I'll rephrase. Can you elaborate on the process for calculating greenfield runoff rates, and how do you ensure accuracy when different LLFAs provide inconsistent data?
So the LLFAs have inconsistent approaches to it, whether they want to use the site area or impermeable area to calculate the greenfield runoff rates. But the national SuDS standards have now defined the process, if you like, so that we can redefine the process, reiterate it, that it's supposed to be the site area you use to calculate the greenfield runoff area. So there isn't any ambiguity anymore.
Okay. And how do you cope with when you have poor or incomplete site data?
We go out and get it effectively.
Okay.
Spend some money, do the survey, do a CCTV utility survey. It's probably easy for me to say that on the developer side because we've probably got a bit more money than some other organizations might have. You know, we have the power to spend a bit of money to get this information if we need to.
Okay, so going out to site and doing your manhole surveys, CCTV surveys, with elevation,
get all the information you need. Yeah.
So I think this is probably going to be my last question, given the time. What are the most common mistakes made when building drainage models, and how can you avoid them, I guess?
Making sure everything is connected, making sure everything runs downhill, making sure it's designed as you want it to be. Just being thorough, I suppose. Making sure you've got the right outfall, make sure it all works from the start. As my example showed, we got the wrong outfall to start off with because we would try and connect to a pipe when the LLFAs and the national SuDS standards point in the direction of discharging to a ditch if you can.
Okay. Well, thanks, Brian. That was great. I think back over to Olivia to round up.
Thank you very much, Idris, and to Brian as well. To wrap up, I would like to ask each of our speakers for a brief closing thought. So your key takeaways of today's discussion. If Simon could start.
Yeah, thank you very much. And it's great to speak with you all. I think it's all around taking your time, ensuring effective implementation of SuDS, having the correct data for it, and following through. Thank you.
Brian, if you'd like to continue.
Yeah, I'd agree with Simon, and being thorough in your design and using InfraDrainage because it's a great piece of software for doing the design and modeling SuDS features.
Okay, thank you to you both. So over the past hour, we've explored how modern drainage modeling techniques are reshaping housing developments, from Brian Jones's practical insights on the Pittville case to Simon Renfrey's expertise in leveraging Autodesk's tools for efficient design workflows. So together, their presentations have shown how moving beyond outdated methods, embracing scalable digital solutions, and integrating SuDS features can help engineers navigate tighter site constraints and meet regulatory demands with confidence. I'd like to thank our speakers Simon Renfrey, Business Development Manager at Simtree, and Brian Jones, Associate Engineering Director at Newland Homes, for sharing their expertise with us today, and also to Idris Nuju for moderating our Q&A. To everyone who joined us, thank you for being part of this session. We hope you have now a deeper understanding of the evolving landscape of drainage design and the tools driving these changes. Before we wrap up, a quick reminder, this webinar will be available on demand on the Smart Water Magazine website. And stay tuned for more webinars in the Autodesk Water series, where we continue to explore innovative solutions shaping the future of the water industry. Thank you, and I hope you have a great day.